Hi everyone, welcome to my channel. My name is Phi Qwen and today we are going to run some AI models locally using Ollama. Yes, so most of the time previously in the previous videos we were using large language models, but we were paying for that. We were using either Copilot Studio or we're using as Azure subscriptions to be able to have those models, and it was not free. In this video, we are going to run them using Ollama, and we are running them locally without paying for anything, but it's just the speed that is not the same as the one online. No API key needed, nothing. Let's get started. So here in this documentation, I share how I have tested Llama 3, Phi Qwen. Llama 3 is the one that is associated to Ollama, and then we have Phi Qwen, I believe is the Microsoft open source model. It's not open source, it's the Microsoft model. And then Qwen is another one for a Chinese company that I've discovered locally, and we are going to do that all together here. Yes. Ollama, what is Ollama? Ollama is like a Netflix for AI models, so it helps us to run those models in our laptop. It's free, it's private, yes. So online, we call remote servers and it costs money per request, and the data leaves our computers, and it requires an API keys, it requires an internet connection. This one can work offline as well, no API key needed. It runs on our machine. So each time that you install a model, it has some space in your local machine. For example, Phi Qwen is about 2.2 gigabytes, and Qwen they have some space, sometimes 4 gigabytes. So it would take some amount in your computer. So let's see how to download Ollama. I already have it. For some reasons, I'm not able to share that screen with you in this application. Llama, you see, it shows a black screen, but I have it installed already. So you just click ollama.com and you select download, and you will have it on your local machine. Once you have that, you go to the terminal. I will go to a project. I already did that as well. Let me go to my VS Code. So I'm stopping the current server that I had. So you just click this Ollama Run Llama 3.2 and it will download it. I already have it, so it doesn't allow me to download anymore, but I can just run it already because I already downloaded it. But if it was the first time, it would have downloaded it in the computer. So right now I can ask a question. I will say, what is the difference between RAG and fine-tuning models? So I can ask questions like ChatGPT, and it will be able to respond, and I can evaluate the quality of the responses. I can evaluate the speed of the responses. So let's see what it does. It's saying in machine learning, particularly deep in deep learning models, there are two types of models updates, RAG or rapid prototyping. I don't believe that. I believe RAG is retrieve augmented generation, so I'm not sure what it's talking about right now. And fine tuning. While both approaches share some similarities, they are distinct. RAG model updates involve making small changes to pre-trained models. That's not true. I'm not sure what is taking this response, but that's not right. The RAG that we all know, it makes a search for your document first before the large language model responds. So that means it has an embedding model that index your document to have that index somewhere so that you can make some AI search. So when a user asks a question, it goes and find the similarity between the user embedding and what we already have on the index based on maybe semantic search and ranking search and stuff like that. So this, I don't agree with this, but let's see what it says for fine-tuning models. It says fine-tuning involves updating the entire pre-trained model. That's true. When you want to fine-tune your model, it uses large language model that are already trained, but it wants it to be pre-trained using your policies data, your local data, your company data, and maybe you want a certain writing style, certain output format, certain behavior of that large language model. So you train it with your data so that it behaves the way you want it to. So that means each time that you want a different behavior, you will retrain the model. Yes. So it's giving me some answers here and I can keep asking. So that was the first part. That's the first model that we have tested. You can do it also on your own and test some of these models. I've also installed Ollama. I also installed Phi Qwen, that is the Microsoft model. Let's run it as well. I will stop this one. Say Control D. So I will run this one. Particularly, I've tested this model. It is very slow, very, very slow. I'm not sure why. What is the difference between RAG and tuning model? And what is interesting is that each time I run this question, it gives me different answers. The first time I asked this question with Phi Qwen, it told me that it was RAG was meaning reconstruction, augmented generation. Now it's saying that RAG is graded abstractive question answering. Each time it's giving me a different answer. Very interesting. It says it's designed for abstractive question answering on web platforms like Reddit. Okay, we don't agree with that, but let's leave it work. I have some other models that we can run, like Qwen 2.5. Let me run that. I will stop this. I will say Ollama run Qwen. So this is the model. I've installed it, so we should be able to use it. I will see if I can run the same prompt. This is the first model that gives me the correct answer about the retrieval augmented generation. The other ones, they were just off for some reasons. Yeah, so they use your CPU and yeah, I have downloaded just those three for now. On your own, you can download many more if you want to. That's okay. We can also download the Google one, Llama 412B. Let's download that model too and see. So the good thing about this model is that you can evaluate them, the quality, the speed. This one, It looks more accurate, but it's very slow. It says fine tuning is when you have specific domain data and when you want to build the top of pre-existing model knowledge but tailor it more closely to your needs. Yeah. It's commonly used in tasks where labeled data is limited and you need to adapt existing model to perform well in specialized domain. Yes, so the RAG or retrieval augmented generation is like you are asking a student to read the workbook before answering the question. Most of the time when you go to the exam, you say to the student to do not read the workbook because when they are doing the exam, they're supposed to have mastered everything. But it's different. The work is that you tell the student, read the information in your workbook before you answer the question. So that's pretty much it. And it's giving me a use case right now that is useful when dealing with tasks that require extensive background knowledge, where user answer might not be directly contained within a single sentence, but rather spread across multiple documents. It's effective in applications such as questions answering system, document summarization, conversational agents, where context and breadth of information are critical. Yes, I would say if you want to change your documentation most often, if you have approvals or approved document or many versions of document like SOP, tactics, policies, those type of document, it's good to use RAG because they keep changing and it will always be indexed on a regular basis and you will be able to have the latest approved document uh, information when you ask. So I will ask, what are two real life example use cases for fine tuning models that we can build now? You say it's powerful way to adapt existing models to specific tasks with limited level data. Here are two real life example. Sentiment analysis for local news feeds. Analyze the sentiment of news articles from different local regions. Why fine-tune? Existing pre-trained model might not have been trained on diverse range of local dialect, idioms, and expressions that are common in local news. I pretty love this model. It's powerful. I never used it before. This is the first time. It's good compared to Phi three that we have tested and compared to the first one. The other one was Llama. So compared to those two, I really like it. So here is giving me talks about mostly sentiments, classification, categorize. You can do better. I believe we can have that, but you can also do better for more complexity. It's a categorize customer support tickets into predefined categories such as technical issues, billing inquiries, product returns. It's a wide fine-tune. A general pre-trained model might struggle to differentiate between specific types of customer queries if the training data is not diverse enough. Fine-tuning allows you to adapt the model to understand the language used in customer support tickets and classify them more accurately based on categories. That's a good perspective, guys. And the third one, it says healthcare text classification. That's classify medical text document. That's a good one. Into different categories such as drug interactions, disease descriptions, treatment protocols, etc. Healthcare healthcare text can be highly specialized and specific in language used. Pre-trained models might not understand the nuances. That's a good one. So while it continue to do that, I will go back to our document. And yes, so we have run the filter, we have run also some other models. So Ollama interface shows all available models, and there are also some cloud ones that necessitate you to have Ollama cloud account. I have taken a picture of how my interface looks like. You are not able to see it because for some reasons the software that I use doesn't show this page, but these are the models that I have. Some are cloud-based. So for me to use, for example, this one, I need to have Ollama account. Yes. But this is very cool because I was able to test the difference between swag and fine-tuning and have some responses between the two and to judge. Yeah. So in the next video, what we are going to do, we are going to build our first rack application. Yes, and we are going to do the interface for that. I hope you had fun with this video and see you on the next video. Ciao.